Okay, good morning, everyone. So we'll continue with our discussion on trigonometric functions. Again, we will try to derive few more trigonometric identities in this session. Okay, so next session, I will plan to do few basic problems. Okay. Okay, so let's start our today's discussion. Okay, so here we need to prove that tan 2x is 2 tan x divided by 1 minus tan square x. And again, we need to make sure that our 2x does not follow this. Okay. Now let's see how to prove this. Now tan 2x, we can write it as, what do you think, guys? I think we have a choice here. Okay, so we can either use tan a plus b. Okay, so what is tan a plus b? We have tan a plus tan b divided by 1 minus tan a into tan b. This is one approach. The other one is, if you want, you can write it as cos sin 2x by cos 2x. Either way is fine. I think we will try and use this. Okay, so tan a plus b is something that we saw last class. Okay, it is tan a plus tan b by 1 minus tan a tan b. I think we saw tan x plus y. The reason I'm using a and b is so that we know what we are really substituting. Okay. Now this tan of 2x, I can write it as, okay, I'll split this 2x into x plus x. So our a is x and even b is also x. Okay, so a is x and then b is x. And then if I use the identity, okay, so this identity, if I use it here, what do I get? Tan of a is tan x plus tan of b is also tan x divided by 1 minus tan x multiplied by tan x. So you would have 2 times tan x by 1 minus tan square x. Okay, is everyone okay?
Yeah, sir.
Okay, so if there are no questions, I think we'll just talk about this domain. Okay, so this is important. Okay, so what are we saying here? The reason why this is not allowed is wherever you have a tan function, okay, your tan function is sine divided by cos, and then you don't want your cos to be 0. Okay, so and again, when is your cos 0? Cos is 0 whenever your x is an odd multiple of pi by 2. Okay, for example, if I write tan 2x as sine 2x by cos 2x, and I don't want, for example, 2x to be pi by 2. Okay, I don't want it to be pi by 2. Okay, and also I don't want it to be 3 pi by 2. I mean, I'm just taking a few examples. 3 pi by 2. So here, if you look at it, what is the difference between pi by 2 and 3 pi by 2? So if you look at the difference, okay, so 3 pi by 2 minus pi by 2, so that is going to give you pi. So you don't want your 2x to be pi by 2 plus another pi. Okay, so you're going to get 3 pi by 2, and again you don't want it to be 5 pi by 2, so another pi by 2. So you keep adding. So just you need to watch out for this. Okay, and these are very useful when we actually talk a little more about functions, because you need to understand that our discussion on functions is not yet over. Okay, so we will be going back. Okay, we'll be revisiting that chapter over our, I think for this year we will be revisiting it now and then. Okay, as we build our knowledge in other areas. Okay, I'll pause here for I think maybe a few seconds. Let me know if you have questions. I think this should be okay, right? So you don't want your 2x to be this. Okay? So not allowed here. Okay, so these are not allowed. So let's look at the okay. This is again very important. Okay, so this is really important. So sine 3x is 3 times sine x minus 4 times sine cube. Okay, so this is very regularly used. So what is that we can really use here? I know I have sine of a plus b. Okay, what is sine of a plus b? Sine a cos b plus cos a and then sine b. So we can use this here. I'll look at the left hand side. I have sine of 3x. So this sine of 3x, I'll split it into x and 2x. Okay, it doesn't matter which one is first. So x plus 2x. And then here, let a be x. Okay, so let a be x. And then let b be 2x. So we are taking this. Okay, so a is x. Did I erase that? Okay. So a is x and then b is 2x. Now just substitute. Okay, so what do we have? Sine of a, which is sine x, and then cos of b, which is cos 2x, plus cos of b, sorry, cos of a, which is cos x, multiplied by sine of b, which is sine 2x. Okay. Now, if you look at the right hand side, you just have sine x. So you don't want to use multiple of x. So we have multiple of x here and then multiple of x here. So we need to convert these two. Okay, so we need to convert these two. Again, if you recall the identities that we saw a few classes earlier, you should find sine 2 of x, okay, sine of 2x as 2 times sine x multiplied by cos x. So this is 1. And cos of 2x, sorry, that is cos of 2x, is cos square x minus sine square x. Okay, so these are the identities that we already saw. So we're going to substitute these two here. Okay, so if I substitute them here, sine x, so cos of 2x is cos square x minus sine square x plus cos x, and then sine 2x is 2 times sine x into cos x. Okay, so here again, wherever you have let's say cos square x, okay, you want to convert that into sine because you don't want anything other than sine. Okay, so you don't want anything other than sine. So let's do that. So I have here sine x multiplied by cos square x minus sine into sine square x. So that is sine cube x. I hope you guys are getting used to this way of writing. Here we don't write sine x whole cube. We write sine cube x. It means the same thing. Okay, it is basically sine x raised to 3. Plus, in the second term, I have 2 times. I have cos x multiplied by cos x. So I can write that as cos square x multiplied by sine x. Okay, now this is another thing that will take some time for you to get used to it. You need to understand that these are like when you provide some values, inputs to x, this function will give you a number. So you're basically trying to multiply these. Okay, so you're trying to add, subtract, and then these are getting multiplied. Okay, so it will take some time for you to
Sir, can you explain the third step again?
Third step again. Okay.
Yeah.
So when you say third step, this one.
Yeah, sir.
Okay. Okay. Now, do you see this cos 2x? Okay. So
Yes, sir.
cos 2x can be written as cos square x minus sin square x. You
Okay.
remember this from previous class, or you want to understand again this one?
No, sir, I want to understand this again.
This one?
Yes, sir, cos 2x equals to
Why
cos
is
square.
this? Okay, okay. So what you can do is, if you look at the cos of a plus b again. So if you take cos of a plus b, cos of a plus b is what? Cos a, cos b minus sin a, sin b, right? And if you take a as x, okay, so you want to take a as x and then b is also x. Okay, so if you do that, okay, so a is x and then b is also x. Then on the left hand side, what do you have? You have cos of 2x. And then here, a is x, b is x. So you have cos x multiplied by cos x minus sin x multiplied by sin x. So what will this give you? This cos x into cos x will be cos square x. Sin x into sin x is sin square x. So minus sin square x. So this is how you get this identity. You're okay?
Yeah, sir, got it.
Okay, so that we have substituted here. So what we have done here is this cos 2x, I just substituted cos square x minus sin square x. And then similarly, you're okay with sin 2x as
Yes, sir. Yeah, sir. Yeah.
okay. And then we just substitute. And then I think we opened the bracket. So sin x multiplied by cos square x, we have it here. And then sin x multiplied by sin square x is your sin cube x plus 2 times cos x into cos x is cos square x. And then you have sin x. Now, like I was saying, the right hand side, we have only sin x, right? So wherever you have cos square x, we want to write that in terms of sin square x. And then we have the other identity, right? So sin square x plus cos square x is 1.
Yeah.
This was the fundamental identity that we started off with. Okay.
Yes, sir.
So here, so cos square x, I can write it as 1 minus sin square x. So I have sin x. So cos square x, I can write it as 1 minus sin square x. So I don't have to change here. Sin cube x will be as it is. Okay, plus 2 times. I have another cos square x. So I'll write that as 1 minus sin square x multiplied by sin x. Okay, so now again, we need to distribute and then collect the like terms together. So sin into 1 is sin x minus sin into sin square x. So you have sin cube x minus you have a sin cube x here. And then plus, okay, so look at this carefully. Okay, I have a 2 sin x into 1. So that is 2 sin x minus 2 sin x into sin square x. So that will be 2 sin cube x. All right. And then again, collect the terms. I think you have now you are having only sin. Okay. So let's look at this. Okay. So you have a sin x here and you have a 2 sin x. So if you club them, you get 3 sin x. And if you look at sin cube x here, you have a sin cube x here, you have a 2 sin cube x. So if you club all of them, I think you will get minus 4 sin cube x. So minus 4 sin cube x. Okay. Are we okay here?
Yes, sir.
Okay. So again, I'll pause here for a minute, understand how we prove this identity. So we are using what we already know and then proving it. Okay. So I'll pause here for a minute. So let me know if you have any questions. Okay, so I am hoping this is okay. So let's look at another identity. Okay, so now you have a similar identity. Okay, so instead of sine, you have cos here. Cos of 3x is 4 cos cube x minus 3 cos x. Again, look at the pattern here. When you are dealing with sine, I think the power 1 term is coming up front and then the power 3 term is coming later. Okay, so you have those 3 and 4. Even here you have those 3 and 4, but the cube term is coming first. Okay, so 4 cos cube minus 3 cos x. Okay. Okay, so here also you should guess that we can use those identities of sum of two angles. So I have cos of a plus b, right? So I can use cos of a plus b is cos a multiplied by cos b minus sine a multiplied by sine b. Okay. Now I can split my cos of 3x again as cos of x plus 2x. Now what is my a? My a is x here and b is 2x. Okay, so a is x. Why do I erase always? Okay. Okay, so yeah, a is x and then b is 2x. Okay, now substitute. Okay, so now let's substitute. So what do we have? Now first cos x, cos a, and then multiplied by cos b, so which is cos 2x minus, okay, sin x multiplied by sin 2x. And again, we are going to borrow those results. So we have sin 2x as 2 sin x multiplied by cos x, and then cos 2x as cos square x minus sin square x. So we will substitute them here. So what do we get here? I think I'll write.
Sir,
Yes.
sir, how is it like minus sin x? I didn't get that one.
Which one? This one?
Yes, sir, my sin x.
Okay. Because your cos of a plus b is this cos a plus b minus sin a plus b.
Okay.
So
Okay, yeah.
you remember, I think that is
Yes,
the
sir,
one
yes.
which we actually tried. Cos of x plus y is cos of x multiplied by cos of y minus sin of x into sin of y.
Okay.
Okay. Yeah, I think you can again go through that video. How we
Yeah, okay.
fine with this, Harsha?
Yes, sir, yeah, fine.
Okay, so now we will substitute these. Okay, so if I substitute, let's say cos x, and then cos of 2x is cos square x minus sin square x minus sin x. And again, so sin 2x is 2 sin x multiplied by cos x. And then here we are interested in cos function. So wherever you have sine, you can replace that. Okay, so now we know sin square x plus cos square x is 1. So sin square x will be 1 minus cos square x. So wherever you have that, you will replace it. So before that, I think it's a good idea to open them up. So what do you have? Cos x into cos square x is cos cube x minus cos x into sin square x minus 2, you have sin x into sin x, which is sin square x multiplied by cos x. So now I think at this stage, replace sin square x with 1 minus cos square x. So you have cos cube x minus cos x into 1 minus cos square x minus. So I think we could have combined. I think it's maybe we could have actually combined these if you wanted. Okay, so it's up to you guys. I think the way you do algebra is up to you. So 1 minus cos square x multiplied by cos x. Okay, so now you have cos cube x minus cos x, and then minus into minus, that would be plus. I have cos cube x minus 2 cos x, and again this becomes plus 2 cos square x. Okay, so if you add the positive terms, you have I think yeah, this is a cube base, that is a cube. So you have 4 cos cube x and minus 3 cos x. Again, we will be using this in the next session when we do few simple problems. Okay.
Okay.
Okay, I'll pause here for a minute. Let me know if you understood this one, or if you have questions. Let me.
Sir, here like cos x at the first step,
First,
cos 2x. Cos 2x isn't it supposed to be in brackets like how it is in this previous problem?
uh, say say that again, Harsha. What is that you're saying?
Like in the previous problem, like sine 2x was in the brackets, sir.
Right.
Then why isn't 2x in brackets here?
Acha, acha. Sine 2x. Why is this not in the brackets? Okay. So
Yeah.
you mean here?
Yes, sir. Here it is in the brackets.
Here.
No,
Huh?
sir. In the first step, cos 2x.
Acha, cos 2x.
2x in the brackets, but
No, this
not.
is not 2x. This is sine square x.
No, sir. I meant like here in the second step, cos 2x, and just 2x is in the brackets, right? Then why
Acha, acha,
isn't it?
acha. Oh, okay. 2x is in the bracket. Okay. Now, usually it's a good practice to use bracket. Okay. So sometimes I don't do that. Okay. But it is actually, it means the same thing. Okay. So if I use cos, and then by the side, if I write 2x, the 2x is the input. It's better you place a bracket. That's a good observation, Harsha. It's better you place a bracket because the bracket gives you an idea that, okay, I am collecting an input. So my 2x becomes an input to the cos function. But sometimes we don't write. Let's say similarly here also, it is understood that this 3x is acting as an input. But as you have pointed out, it is always a good idea to include a bracket there so that we know that whatever is coming inside that bracket is the input to the cosine function. Yeah, that's the, yeah, that sometimes is understood, but it is a good idea to place the bracket. Okay, Harsha?
Yeah, okay, sir.
Yeah. Okay, so if there are no other questions, let us move on. Okay, so now wherever your 3x is not n pi plus pi by 2, okay, so we need to prove this. Okay, and again, why you understand, right? Whenever you write tan of something, you can actually express it as sine of that value by cos of that value. So you don't want your cos function to return a value 0. Okay, so for that reason, so this restriction is placed. Okay. Now again, I think the proof will be similar to what we did for sine 3x and then cos 3x. So we have tan of a plus b, right? So tan of a plus b is tan a plus tan b
By 1
divided by 1 minus
tan
tan a multiplied by tan b.
by tan b.
Okay, so here, let's split the left-hand side, tan of 3x as tan of x plus 3 plus 2x. Okay, so my a will be x and then b is 2x. Okay, so these are the substitutions that I make. And then if you do that, so what do you get here? So you get tan of a, which is tan x, okay, and plus tan of b, which is tan of 2x, divided by 1 minus
tan x.
okay. I think I was a little slow there. So tan x into tan of 2x. And I think a little while ago, we proved tan 2x. Again, tan 2x can be obtained from here, right? So tan 2x will be, if you recall, so tan 2x is 2 tan x by 1 minus tan square x. Now, if you don't recall or it doesn't strike to you, you can again use this expression. Okay, so you can use this and then substitute a equal to b equal to x. You will end up having this. Okay, so you should get this. And then that is what we're going to substitute. Wherever you have tan 2x, you substitute. Okay, so you have it these two places. So again, pay attention to the right hand side. So I have tan x plus here I have 2 tan x by 1 minus tan square x divided by 1 minus tan x multiplied by 2 tan x by 1 minus tan square x. Okay, another thing is, so even though we are actually trying to derive all these identities, sometimes maybe when you solve problems, you might use basic identities. Okay, so try to practice with as many identities as possible, but don't try to stress on like literally remembering them. Okay, so as you do more and more problems, you will remember, or at least you will know how to get them. Okay, so this is one important thing that you must keep in mind. Okay, your focus should not be to kind of cram all this in your brain, and then don't worry that like there are so many results. Okay, so everything you should be able to get from few results. Okay, so this is what we are trying to do, right? We have cos of minus x as cos x, and then sine of minus x as minus sine x, and then we derived one identity which is cos of x plus y, which is cos x into cos y minus sin x into sin y. Okay, so we have been using only those to get all these identities. So now let's finish this here. So if you look at the numerator and the denominator, you have this 1 minus tan square x. Okay, so you can take that as the LCM. So I think maybe it's a good idea to write this by 1 and then this. Okay, so I think you don't have to. So this is just by 1. So what will happen? Your 1 minus tan x is the LCM. So I have 1 minus tan square x, sorry, 1 minus tan square x. And in the numerator of the numerator, so you have tan x multiplied by 1 minus tan square x plus 2 tan x. Okay. And in the denominator, you have, I think, 1 minus tan square x minus tan x into 2 tan x, which is 2 tan square x divided by 1 minus tan square x. Okay, so guys, I'll pause here. Let me know if you have understood this. Okay.
Sir, can you explain the third step?
Okay, so third step, you mean this one?
No, sir, second step.
So this one, okay.
Yes, sir. Yeah.
Okay, so what I'm trying to do is, so you look at this tan 2x. So tan 2x is 2 tan x by 1 minus tan square x. Okay, so wherever you have tan 2x, I have substituted. Okay, so you have tan x plus tan 2x. So I have substituted here. So 2 tan x divided by 1 minus tan square x. And then in the denominator, I have 1 minus tan x multiplied by tan 2x, right? So I did that. Okay, so tan x multiplied by this 2 tan x by 1 minus tan square x. Okay?
Yes, sir. Yeah.
And then do you follow what we did here?
Yes, sir. Yeah.
Yes, okay, okay. So then can you really see, can you see here that I think we can forget about this too, right?
Yeah, we can.
Okay, so then it's just you collect the terms. Maybe I need a, okay. So I think after ignoring those 1 minus tan square x, so let's open up. So tan x minus tan x into tan square x will be tan cube x plus 2 tan x divided by, I think this is 1 minus, it's just tan square x minus 2 tan square x. So that is already 3 tan square x. So in the numerator, so what do you get? You get tan x plus 3, 2 tan x is 3 tan x minus tan cube x. This is a little hard to remember actually. So 1 minus 3 tan square x. Don't you think, guys? This is actually a little harder. Okay. So this is hard. So I don't want you to stress on this. Okay, so it's better you remember tan of a plus b. You and then think that okay, I can always get this. Are you guys okay?
Okay, sir.
Because you have everything here. You have tan x, you have tan cube x, and then you have tan square x. Okay, so I feel it is a little hard to remember such things. Okay, so I'll pause here for a minute. Let me know if you have any questions. Okay, so if there are no questions, let us move on. Okay, again, these are very useful. Okay, so these are extremely useful. You use them regularly. Okay, so use this regularly. So what are we saying here? Cos x plus cos phi is 2 times cos of x plus y by 2 multiplied by cos of x minus y by 2. Okay, so how do we understand that? Now, look at this, guys. I have cos of a plus b. So I start from cos of a plus b is cos a multiplied by cos b minus, right? So there is a minus here. So sine a and then sine b. And you have cos of a minus b. Okay, so cos of a minus b is cos a into cos b, and then you'll get a plus sine a and then sine b. Now, if I take these two, okay, so maybe I'll call this as the first identity and then this is the second identity. So if I add these two identities, okay, so on adding 1 and 2, okay, so I just add 1 and then 2. So this is going to give me, okay, so it gives what? On the left hand side, what do you get? So you get cos of a plus b plus cos of a minus b. Okay, so cos of a plus b and then cos of a minus b. On the right hand side, if you have noticed, you have a minus sine a into sine b, you have plus sine a into sine b. When you add, that gets dropped. Okay, you are left with only cos a into cos b. So you will get on the right hand side, you have 2 cos a and cos b. Now, whatever identity that we are trying to prove, it looks similar to this, right? Except that if you look at x, okay, if you look at x, maybe that is getting mapped with a plus b. Okay, so if you look at y, that is getting mapped with a minus b. So what we can do is, you will substitute x as a plus b. So we are saying a plus b, let a plus b be x. And we are saying let a minus b be y. Do you see this? Then what will happen? On the right hand side, you have a and b. So you have like two simple equations to solve. If you add them, what do you get? If you add b and b will disappear, you'll get 2a as x plus y. So your a becomes x plus y by 2. So similarly, if you subtract these two, okay, so if you subtract the second equation from the first equation, a gets dropped, you have b minus b, so that would be 2b. Okay, so 2b will be x minus y. So your b becomes x minus y by 2. Okay, are you able to follow this?
Yeah, sir.
Okay, so you have a and b. Now take those and then substitute here. Your a plus b is x. So that means this is cos x. Your a minus b is y. So that is cos y. And the right hand side, you have 2 cos a. So that means that is x plus y by 2. And then cos b, which is cos of x minus y by 2. Okay, so this is again one of those identities that are extremely useful. Okay, so you will see as we do talk. Okay, so what we are saying is, if you have cos x plus cos y, okay, you have a summation here. You want to write it as product of two cos functions. So then it will become 2 into cos of x plus y by 2 multiplied by cos of x minus y by 2. So do you understand this identity? Yes.
Yes, sir. Yeah.
Okay, so anyway, I'll pause here for a minute. Let me know if you have any questions. Okay, so if there are no questions, I think let us move on.
Yes.
Okay, so now you have, let's say we have just seen cos x plus cos y. Now we are saying cos x minus cos y. The idea is still same. Okay, so the idea is like you are still going to start off with these two identities. Okay, so maybe let me copy these. Okay, I'll start with these two identities. So if I bring them here, okay, so if I have these two identities, 1 and 2. So in the previous case, we actually didn't want sign values, sign into sign, but now we want. Okay, so now we want. So what we can do is we can subtract the first equation from the second equation. Okay, so 2 minus 1. This is what we're trying to do. So this gives what? Okay, so this will give us what? On the left hand side, you have cos of a minus b minus you have cos of maybe I think there is a minus sign anyway right here. So I think I'm going to change my approach case. Maybe I'll do 1 minus 2. Okay, so because there is anyway minus sign, so we'll do 1 minus 2. Okay, so I'll do 1 minus 2 gives. So it gives cos of a plus b minus cos of a minus b. This will be, now this time cos a into cos b, that will disappear. Okay, so that will vanish. And then you will end up having minus 2 sine a into sine b. Now, if you go back what we did, okay, so earlier, okay, so this is something that is still valid, right? So we can still use this. Okay, so maybe I'll copy this and then paste it there. So I can still use that. Okay, so this is still applicable. Okay, so your a plus b is x, a minus b is y. So you can get a as x plus y by 2 and then b as x minus y by 2. So okay, so you understand this. So let's remove that. And then a plus b is your cos x minus cos y, and then minus 2 into sine of a is x plus y by 2, and then b is x minus y by 2. Okay. So, okay, again, I'll pause here for a minute. Let me know if you have questions. But here, the difference is you have sine, but at the same time you have a minus. Okay, so this minus is important. So pay attention to that minus. Okay. So if you don't want minus, maybe you should write on the left hand side cos y minus cos x, but I think we should try to retain this pattern. Okay, so I'm assuming there are no questions, so let's move forward. Okay, now again, so we did with cos, now we are trying to do with sine. Okay, so again, let's write the identities that we know for sine of a plus b and sine of a minus b. So sine of a plus b is sine a multiplied by cos b plus cos a multiplied by sine b, and then sine of a minus b will be sine a cos b minus cos a and then sine b. Now we can add these two. Okay, so we are adding these two. Okay, so 1 and 2. Okay, so 1 plus 2. So if you add them, so what do you get? So you get sine of a plus b plus sine of a minus b. So what should we get here? So we have, I think that cos A into sine B. So these terms will disappear. Okay, so adding these will disappear. So you end up having 2 sine A cos B. And again, so if you go back, we substituted x for A plus B and then y for A minus B. Okay, so if you do that, the left hand side becomes sine x plus sine y. And then 2a becomes x plus y by 2. Okay, so that is sine of x plus y by 2. And b becomes x minus y by 2. So cos of x minus y by 2. So this is the identity. But I think I made a mistake in typing down. So guys, do you see the mistake here? I think we don't want that minus sign there. Okay, so there is no minus sign. Are we okay?
Yes, sir. Okay.
So again, I'll pause here for a minute. Again, I'm emphasizing these are extremely useful. Okay, use them here, use them in physics. Okay, so use them repeatedly. Okay, so if there are no questions, let us move on. Okay, so now here you have sine x minus sine y is this. So we can borrow these identities here. Okay, so we can, let's copy them and then use them. So let's put them up here. And then now if I do, let's say 1 minus 2. Okay, so equation 1 minus equation 2, that is going to give us sine of a plus b minus sine of a minus b. And then this time you have that sine a into cos b. The first two things will disappear. Okay, so these will disappear, and the green ones will be there, well, the green shaded ones. So what do you get here? So you get plus minus, it will become plus. So you have 2 cos A and the sine. And again, A plus B is x. So sine x minus sine y is equal to 2. A is x plus y by 2. And then B is x minus y by 2. Okay, so this is the idea. And again, I think my copy paste mistake is carrying forward. Guys, please note that we don't need that.
No, there's no minus. I was going to say, I was like, did I learn something wrong? Yeah.
These are all, kya bolte hain, Microsoft. No, actually not Microsoft. Copy paste mistakes. Yeah, so all coders use cut, copy, paste tools. Yes. Are we okay, guys?
Yes, sir. Yeah.
Okay. So let's move on then. Okay. So now, again, so these are like dependent on what we just did. Okay. So they're kind of, let's say, now we want, you have a product, you're going to sum. Okay. So now look at what we have here. I think, let's say, if I, okay, so sorry. Let's say if I want this, okay, what can I do here? So I already have this, right? So cos of A plus B plus cos of A minus B. So if you think about it, okay, so we already have here, maybe I'll borrow from here, okay? Cos of A plus B, yeah, I think I have this here. Na? I will borrow this from here. Okay, so this will be good enough. Okay, so let's go to that slide. Okay, so I'll put it here. And then you'll immediately see, maybe not immediately, but if can I exchange the sides? Okay, I can exchange the sides, right? So I can write 2 cos of cos A cos B is equal to cos of A plus B plus cos of A minus B. Okay, now do you see, it's just, we are replacing here X
A.
with A, Y with B. You see this?
Yes, sir. Yeah.
Okay, so this result should be okay, right? And I think even this should be okay. Okay,
Yeah.
or if you want to start off from the right hand side, you could open that up. Okay, so cos of X plus Y, I mean, if you want to do it afresh. So this is cos X, cos Y minus sin X, sin Y. And then cos of X minus Y will be cos X into cos Y plus sin X into sin Y. And then we are taking a difference. Okay, so if you take a difference, what do you get? Cos of X plus Y minus cos of X minus Y. I think this cos X into cos Y will disappear, and then you will get, you should actually get minus, okay, there is a mistake here, right? Can I say there is a mistake? There is a mistake, isn't it? So, because the left-hand side you have cos, okay, I think there is a mistake here, guys. Do you see this mistake? 2 sin X and sin Y aana chahiye. So how should I fix this? So this has to go, right? Do you see that?
Yes, sir. Yeah.
Okay. I think I should use a thicker one. What is it? It's taking time. Oh, okay. Now it is better. Okay. So this should be minus 2 sin X into sin Y. Okay. Again, I need to do work on my proofreading. Okay. But you understand, yes?
Yeah, sir. Yeah.
Okay. So let's move on. Okay. So again, this is a similar one. Okay. So maybe we can start from the right hand side. You see, once you follow the basic identities, then the other things should quickly fall on place. But again, so don't be overconfident, because this is not the end, right? So you should get into a position where you are actually solving as many problems as possible. So that is what you should aim at. So sin of X plus Y is sin X into cos Y plus cos X into sin Y. And then similarly, sin of X minus Y, right hand side में अगर देखें, so sin X into cos Y minus, okay, so cos X let's see if I've made any cut copy mistakes here. Sine y. So we are adding them. Okay, so if you add them, x plus y plus sine of x minus y, I think these terms will drop off. Okay, so these terms will drop off, and then you will end up having 2 sine x cos y. I think we are okay here. So it's like this is a very important thing. And you have a sum on one side, you are going to the product of these trigonometric functions, or you have product of trigonometric functions, you are going towards sum of the trigonometric functions. So this is like you will need it. Okay, you will see. I'm hoping this is okay, so we can move forward. Okay, so the last one again, so I can just quickly borrow these, right? So I can borrow these to prove that. Okay, so I have this. Okay, so here, what do? I just subtract. Okay, so the second equation from the first one. Okay, so sine of x plus y minus sine of x minus y. So the first things, these will drop off. Okay, so these will drop off. Sorry. Okay, so these will drop off. And then you will have 2 cos x sine y. Okay, easy guys, identities. Easy.
So could you go to the previous page once?
Previous page once, okay, yeah.
Yeah, that's all. Thank you, sir.
Yeah, okay, yeah. Okay, so I think what we will do is, we will meet on Friday. So till that time, try to go through them. Okay, so we will be using them. Okay, so in the next class. Okay.